Let's perform stoichiometry calculation using the ideal gas equation. So, if I have two substances that I name as substance A and B, we could find the moles of substance B if we have the moles of substance A. To find the moles of substance A, we can use an information such as mass, number of particles, volume at standard temperature pressure or room temperature pressure if A is a gas, or from the pressure, volume and temperature of gas A if A is an ideal gas. So if B is an ideal gas, we could find the pressure, volume or temperature of gas B if we have the moles of B. Let's recall what we had learned in chapter 1. From the mass, we can find the number of moles by using a formula. Number of moles is equals to mass over molar mass, or you could also use a conversion factor where the molar mass of A is the mass of A in 1 mole. So let's put the mass of A here in X gram. So the mass of A in gram times with 1 moles of A divided by the X gram of A in 1 mole. So we will cancel out the gram and we will get the moles of A. From the number of particles, we know that 1 moles of any particles in this world is equals to 6.02 times 10 to the power of 23 particles. So the particles can be in atoms, molecules, or ions. So if we have the information about the number of particles of substance A, we are going to times it with 1 moles and divided it by 6.02 times 10 to the power of 23 particles. So cancel out the particles, we will get the moles of A. At standard temperature pressure, 1 moles of any gas is equals to 22.4 liter, while at room temperature pressure, 1 moles of any gas is equals to 24.0 liter. The standard temperature is 0 degrees Celsius and the pressure is 1 atm, while at room temperature, the temperature is 25 degrees Celsius and the pressure is also in 1 atm. So, to find the number of mole of A at STP, the volume of A times it with 1 moles divided it by 22.4 liter, while at room temperature pressure, the volume of A times with 1 moles divided it by 24.0 liter. So make sure the volume here is also in liter so that we can cancel it out. If A is an ideal gas, from the information of its pressure, volume and temperature, we can find the number of mole of A by using this formula. PV is equals to nRT. So this is the ideal gas equation formula. Alright, so the number of moles of A is equals to partial pressure of A times the volume divided by RT. So let's have a look at an example. So we have an absorbent that's regenerated when hot hydrogen reduce the copper to oxide, forming the pure metal and H2O gas. On a laboratory scale, what volume of hydrogen at 765 torr and 225 degrees Celsius is needed to reduce 35.5 grams of copper to oxide? So the first step, we need to know the reaction equation, a balance equation between the copper to oxide and the hydrogen gas that will form a pure metal and H2O gas. So the copper to oxide is the CuO, okay, solid, react with the hydrogen gas, forming a pure metal. So the metal here is the copper and also the H2O gas. Balance the equation. Looks like the equation is already balanced. So from the question, okay, the question asks you to find the volume of hydrogen gas, okay, when the pressure is 765 torr. Okay, this is the pressure and the temperature is 225 degrees Celsius. And also here we have the mass of the copper 2 oxide. So from the mass of the copper 2 oxide, we can find the number of moles of copper 2 oxide. Since the molar mass of the copper 2 oxide is 79.6 gram, so we know that in 1 moles of copper 2 oxide, the mass is 79.6 gram. So 35.5 gram of the copper oxide, okay, times it with 1 mole of the copper oxide divided it by 79.6 gram. Okay, cancel out the gram, we will get the moles of copper oxide. From the balance equation, we know that 1 mole of copper oxide equivalents with 1 mole of hydrogen gas. So, to find the moles of hydrogen gas, use the conversion factor, okay, cancel out the moles of copper oxide, we will get the moles of hydrogen, which is 0.4460 mole. By assuming hydrogen is an ideal gas, we can use the ideal gas equation to find the volume of the hydrogen at a given temperature, pressure, and the number of moles. Substitute all the information into the equation, but don't forget to change the temperature in Kelvin and also the pressure in ATM.